Hey quad folks, today I'm going to be centering a 2-inch quad head drum on the motor shaft uh, before balancing. It's a whole lot of fun. To give you just a little background here, uh, what I'm going to do is we need to take this drum, which if you followed in one of the previous videos, we had removed this from a seized Mark 20 head assembly, and we had lapped the surface down. And so now I want to put this in a test head, a Mark 10, and test the playback of the tips. And so what we have here is we have our drum, and then we have the motor shaft, and on this end we have the tachometer disc mounted. Now, there's not anything to do here as far as centering this disc in relation to the center of the motor, because the this little journal shoulder here on that end of the shaft and this hole through your tack disc is a tight fit. See, that's, you have to press that on. So there is no play there, or so there's nothing to center. It centers when you press it on because it is a tight press fit. This end, however, that the drum attaches to has got a couple of thousandths of difference between the diameter of this shoulder and the diameter of this hole. So when you put it on, you do have a little bit of end play side to side. And so you have to center that up before you tighten it down and get it, as centered as possible. If you can't do that, then there's not a whole lot of point in going any further as far as balancing. If this is not centered, the eccentricity is not minimized before going to that step. It's one thing to spin up a finished drum where you have all these different pieces and different weights interacting, rather than if you just have the one piece, or the drum itself, where you just have one piece of metal. You can sort of get away with it a little bit more when you're just doing a spin test on just the naked drum itself, because you don't have anything attached to it. And you can, most of the time you can get by with centering, and that's about as far as you can go, or static balancing, which if you get it centered, you're going to be pretty much in static balance, because there's nothing here that will affect the the weight displacement or the geometry that much. But when you get into this a built-up drum, then you have all these other pieces and weights and you know, interacting, and of course you can't really get away too much with static balancing one of these, you know, standing still, as you can just a solid single piece. So in order to really spin balance one of these, first you have to get it centered on this shaft from the center of the motor, you know, out to the edge, and minimize the eccentricity. Well, to get started, we will do a little bit of assembly here. And so I have a balancing collar without any slugs in it, just the collar and the machine screws, the head bolts. And we'll get it all put together here as one unit. And we just hand tight. We just don't need to tighten anything at this point. We're just running them down to the end of the threads, hand tight. Now, let's see if we can make our way out to the back through all of this maze of junk and stuff. So here we are now out here in our back room workshop, and what I found that works pretty good for this is I just have a little small benchtop lathe, a metal turning lathe, and I have a dead center in a collet instead of the chuck, and then I have another dead center here in the tailpiece. And if you notice, you know, on each end of this motor shaft you have a small hole, and so what you do is, well, you mount this between the dead centers and tighten it up, but not too tight, just snug. We don't want to hurt anything. Now, next we need to establish our accuracy. So what I'm going to do is First, I'm going to check the shaft to see how centered we are. So we'll go down to each end of the shaft and we'll run our vise in till we get some contact. Now, okay, see, that's got some, it's a little bit off center. Okay, I think that fixed it. We're looking pretty good now. Let's go around one more time here, get a little bit more force against that. Okay, so that's looking just about dead on. That's what we want. So let's go up to the other end and see how good this is looking here. Okay, we're looking right dead on, centered. And just for curiosity, we'll go right behind the drum and we'll check this end of the shaft. Let's make sure we don't get too close to the tips with anything. Okay, we're dead center. So that establishes our accuracy. Now we can come over on the drum and take us a reading. Now here I'm not going to put a whole lot of spring tension against our feeler. Just enough to obtain a good reading is all we need. We don't need a lot of tension there. Okay, right there. We're out about 3/10,000ths. tighten the screws a little bit right there. Don't take much. Alright, it slipped over just a little bit. when you do this, be very, very certain that you're not letting it snap down on a tip. Now that will cause damage if you do that, but against the outer edge, the rim of the drum, it won't do any harm, because the drum metal is a lot harder metal than the stylus. And actually it would be ideal if you were to use a nylon stylus instead of a metallic stylus for the end of your micrometer. But just always make sure when you're rotating and tapping using the stylus, is don't be over a tip when you do it, you know, because that could and would damage your tip, the force of that spring stylus against the tip. Okay, so that's, I think, about as good as it's going to get. And so now we need to tighten these screws a little bit and see if it moves when we tighten it. Okay, so we're within about 3/10,000ths, which is about as good as it's going to get. And now what I was doing here was with these screws just hand tightened, you find the lobe, you know, where it's out the most on this side, and there's a spring on this little stylus. You can pull it back and just bounce it against the end of the drum, and that'll move this just ever so slightly. So you do that and you rotate and you do it and rotate, and you finally get it down, you know, to where you can get it no further or can't improve it anymore, and that's, you know, about as centered as it's ever going to get. And now this stylus on the end is chamfered, so when you're riding on the rim of this drum across these tips, there's not really any danger of doing any sort of physical damage to the tip, you know, because we're not moving very fast. Everything is clean, and we have a nice polished chamfered stylus on the end of our mic gauge, so it'll glide right over the tip, the transition from the drum to the tip. and you'll see a little dip in the meter, but that's about it. So we've gotten it down to within about 3/10,000ths now, according to our mic gauge. And to go back and just to make sure we haven't lost our center on the shaft, we'll check that one more time just to be sure. And of course we haven't. That looks just fine. And that looks the same as it did. And that looks the same as it did. So we're all centered up now. I'll put you down here, and then I'll take our drum and shaft out of our lathe. So now we have a centered up drum on our shaft, and now we can assemble this back into the motor by taking this end off, the tack disc end. And if you remember, I said earlier, this whole alignment is a press fit. There's no play here. It goes on tight. So we can take this off and on, and without, having any problems with eccentricity alignment. And so once we do that, we'll be ready to spin balance this monstrosity of a thing.